Okay, so we're going to go ahead and start looking at our next unit, which is conic sections. And a conic section gets its name from the way a plane can intersect a cone, and actually like two right cones stacked. Well, it's not a vertex; it's actually called an apex here. And so the geometry of it, you don't necessarily have to know, although it's interesting. But the way that plane can intersect these two cones will form our four conic sections. And so the one we're going to start with first is a circle. And a circle we've studied in the past outside even the context of a conic section. But if you took your plane, and intersected, thought I had a pen. There we go. And intersected that cone such that the plane is parallel to the base of that right cone, then you'd create a circle. And then if you start to like angle that, and that's kind of what the image below there to get that ellipse, right? So if you would have angled it, this plane down here, then your circle sort of gets stretched. That's called an ellipse. And so really a circle is technically an ellipse. It's just it has no eccentricity, and that's something we're going to study later on in this unit. So there are certain conic sections that are called degenerate conic sections. And what that means is that algebraically, they look like they should be a conic section. And so, like, if you remember, like, one of the things you studied in geometry are equations of circles. So, like, x squared plus y squared equals 100, right? That's an equation of a circle centered at 0, 0, whose radius is 10. Now, you could get something that looks like an equation of a circle, like, for example, x squared plus y squared, let's say, plus 100 equals 0. So at first glance, that looks like an equation of a circle. But as soon as you subtract that 100 over to get negative 100 there, you realize that x squared plus y squared can never equal negative 100. And so it almost has the format of a circle, but it's not going to give you a graph of a circle. So we call that like a degenerate conic section. So one of the degenerate conic sections is the empty set. Like there is no intersection. So none would be like one of them. Like there's no intersection. Okay. So another one could be that if your plane, like thinking about this plane, what if your plane goes exactly through that apex, right through there? So then you've got a circle that's a radius of 0. In other words, it's just a point. And again, like you could easily change this equation of a circle to say like, x squared plus y squared equals 0. So somehow you have you have the algebra, but geometrically saying it equals to 0 makes no sense. In terms of an actual circle we could graph. So a point is another type of a degenerate conic section. And there are two more, actually. If you think about this plane that's slicing through and giving you these two branches of hyperbola, if that plane actually sliced through the exact diameter of this circle, so going this way and this way, I guess you could have any diameters, really. But if you slice exactly through the diameter of that, so then your branches actually will just become two intersecting lines. So that's another degenerate conic section, two intersecting lines. And your last one is if your plane, and this is from a parabola, if that just basically sits underneath this cone and right on top of that cone. Like somehow you can go just down the slant of that. So if you're, again, thinking about, thinking three-dimensionally here. So your plane is laying right on top of this, but yet right below that on that side, you would just get one line. Now, we're going to talk more about the four degenerate conic sections as we move through this unit, and those last two, especially at the latter end of this. But for now, even today, though, algebraically, it should make sense that, no intersection could come from having a quadratic equal to negative, or a point that's really a circle of radius 0, which could have a quadratic equal to 0. So those are the geometric interpretations of these degenerate conic sections. Now, starting off with circles, there should be some things that look familiar in this section. One of them is our general equation of a circle, which is here. X minus h squared plus y minus k squared equals r squared. And the h and the k stand for the center of your circle, and r squared is sitting here, so r would be the radius. And, kind of just going through this first example here. So suppose I give you this equation. So you should be able to pick off of that equation the center and the radius, right? So the center would be equal to whatever makes this equal to 0, whatever makes that equal to 0 component-wise. So that's -4, 6, which is why I have this. And this represents the radius squared. So the square root of 49 is 7. And again, thinking like geometrically, even though the square root of 49, if I'm introducing it, is a plus or minus 7, the fact that it's a positive distance, because it's a radius that's measurable, it'd be positive 7. Okay, so let's get some equations of these circles. And feel free to pause the video, fast forward the video if you know the answers already, and then just check your work. So there's our center. Maybe I'll pick a different color just so it shows up a little better. Maybe this orange. So there's our center. And so that's over 1, 2, 3, 4, 5 in the x direction, 1, 2, 3 in the y direction. So the center is 5, -3, which would mean I would need an x minus 5 squared plus y plus 3 squared equals, and if you count the radius, what is that? 1, 2, 3, 4. So then 4 squared, which is equal to 16. Okay, next, let's find this center. So kind of coming down, if you draw the diameters that are the largest vertical and largest horizontal line in this orientation, you can find that center right there. So it's over 1, so it's -1, and up, what is that? 1, 2, 3, 4, 5. 5. So my center would, equation of my circle would be x plus 1 squared plus y minus 5 squared equals, and then our radius I think was 6. So let's check that. 1, 2, 3, 4, 5, 6. So 6 squared, which is 36. Okay. This guy right here, again, thinking like drawing those diameters to find that intersection point. So that's over 2 for the center. So it's 2 comma, and it's up 1, 2, 3, 4, 5, 6, 7. So it's 2 comma 7. So then I could say, okay, that's x minus 2 squared plus y minus 7 squared equals 4, because the radius was 2, and 2 squared is 4. All right, our last guy here, maybe drawing that diameter, just to kind of see where that center is. So it looks like, oh, it's so small. My eyes are getting, I can tell I'm getting older. Let's see, 1, 2, 3, 4, 5, 6, 7, 8. It looks like -8 up 1. So that would be x plus 8, because we do the 0 squared, plus y minus 1 squared equals, and the radius of, I want to say it's 6 again. Let's see, 1, 2, 3, 4, 5, 6, which is equal to 36. So there's our 4 equations. And again, that should seem familiar. Now, here I'm a kind of similar kind of question, right? That the endpoints of the diameter or of a diameter is given, right? The equation. So I again just think geometrically this might be easier than maybe completing or than using distance formula. But so if I go over 4 and down -1, and then, oh wow, I totally misjudged this one. Over 16 up 7. I mean, I could use the distance formula, figure out what the distance is, divide by 2, use that, right, and then find that distance, or just use the fact that you know that's a diameter. So you already know that that's a midpoint. So then just use the property of that it's halfway between the x and the y. So if this is the midpoint, like, right, the x comma y, then the x will be halfway between 4 and 16, and the y will be halfway between -1 and 7. So 4 plus 16 over 2, like calculating that average. And then 7 minus 1, or 7 plus negative 1, however I look at it, over 2. That'll be a really quick way to get that without having to use the distance formula and get square roots. So 20 over 2, which is 10. And then 6 over 2, which is 3. So there's our center. So right now, I already know that it's going to be x minus 10 squared plus y minus 3 squared equals. And then again, thinking about maybe like here, like from 10, like this is 10 comma 3. So I went to get to 16, I went over 6 in the x direction. And from 3 to 7, that's up 4. Or you could have said from 4 to 10, that's still over 6. And then from negative 1 to 3, that's up 4. So like I know that, I have two right triangles here. And so then I can find this just using Pythagorean theorem, square root of 6 squared plus 4 squared. So the square root of 36 plus 16. So it's the square root of 52. But the thing is, I don't have to worry about simplifying the square root of 52 because I'm just going to square it here, right? The square root of 52 squared just becomes 52. Because remember, this position always represents r squared. Cool. All right, so there's that equation. So let's do the next two. Very similar process. So 13 negative 2. 13 negative 2 sits here. And then negative 13 5 is up here. And again, think about like the average of the x values would be negative 13 plus 13, which is 0. 0 over 2 is 2. So I know my center is 0 over 2 is 0. Sorry. So my center is 0. And then 5 and negative 2 is 3. Half of 3 is 1.5 or 3 halves. So then I would say, okay, my circle's equation is x squared plus y minus 3 halves squared equals, and we do the radius. So again, thinking about going over 13 and up from 1.5 to 0.5 is up 3.5. So it's over 13 up 3.5, or you went over 13 down 3.5. So I want to do the square root of 13 squared, which is 169, and then 3.5, which is 7 divided by 2. So 7 divided by 2 squared, which is 49 fourths. And then, that is my radius. I'm squaring it here. So that just becomes whatever 169 plus 49 fourths is. And then we can actually simplify that by finding a common denominator, which would be 4 over 4. So if you multiply this by 4 over 4 and add it to that 49, so 4 times 9 is 36, carry my 3, 24, 25, 26, 27, carry my 2, so it's 676, if I did that right, 36, and then divide by 4 plus 49 fourths. And so then finally, I know, right, lots of fractions in this video, y minus 3 halves squared equals, so if that would have been 50, that would have been 726 minus 1 is 725 fourths. Okay, whew. One more to go. And this one is a little bit maybe intimidating with your roots, but now realize that if the x component is in a root, like that's a both root 2, and the y component is both in root 3, it makes averaging so much easier to find that center. That would be 2 root 2 plus 12 root 2, which is 14 root 2 over 2. So that would be 7 root 2. And then 4 root 3 minus 8 root 3 is negative 4 root 3 divided by 2 is negative 2 root 3. So there's your center. Oh, it's a messy word for saying center. Let me try that again. Or it's messy penmanship, I should say, for center. That's my center. Okay, and then thinking about how do I get from 7 root 2 to 12 root 2, I went over 5 root 2. So my triangle, if I go over 5 root 2, And then to get from -2 up to to 4 or down to -6, -8, I should say, that's a distance of 6√3. So this squared plus this squared equals that squared. If you square that, that's 50, because you're squaring each of the components. If you square this, that's 36 times 3, which is 108. And so then the square root of that, which is 158. But again, since it's representing radius squared, all I really care about is that 158. So then it becomes, I guess I could write it down here, x minus 7√2 squared plus y plus 2√3 squared equals 158. Okay. I really apologize. It's so messy. In fact, I'm just like ashamed by that. So if I rewrite that, x minus 7√2 squared plus, this should be y. Didn't look like a y, plus 2√3 squared equals 158. There we go. Okay, so hopefully that makes sense. And I'm actually gonna do one more video of the first, or of 2 of the homework problems. So work through those, or you could try them on your own and then check the video answers.